The production of flat glass used for windows, facades, and other applications is primarily done through a highly refined industrial process called the float glass process, though artisanal methods involve different shaping techniques. The float glass process, invented by Sir Alastair Pilkington in 1952, is the dominant method for producing high-quality, perfectly flat glass sheets. The main raw materials are silica sand, about 70 to 75%, soda ash, sodium carbonate, to lower the melting point, limestone and dolomite, calcium and magnesium oxides, to act as stabilizers and improve durability, and cullet, recycled glass, which reduces energy consumption. These materials are precisely weighed, ground into fine particles, and thoroughly mixed in a batch house. The raw material batch is fed into a large furnace and heated to extremely high temperatures, typically between 1500 degrees Celsius to 1600 degrees Celsius, or 2700 degrees Fahrenheit to 2900 degrees Fahrenheit. The silica sand melts and transforms into a molten viscous liquid. Refining and homogenization occur in the furnace to remove gas bubbles and ensure a uniform chemical composition. The molten glass at about 1100 degrees Celsius flows gently from the furnace onto a large bed of molten tin. The glass, which is less dense than the tin and immiscible with it, floats on the surface, similar to oil on water. This creates a perfectly level, mirror-like surface on the bottom of the glass ribbon, which is known as a fire finish. The thickness of the glass ribbon can be precisely controlled by adjusting the speed of the line and using top rollers, knurls, to stretch or compress the ribbon. As the glass leaves the molten tin bath, now at about 600 degrees Celsius, it enters a temperature-controlled furnace called an annealing layer. The layer slowly and gradually cools the glass ribbon over a long distance, up to 200 meters. This controlled cooling process, called annealing, is crucial because it removes internal stresses that develop during formation. If the glass were to cool too quickly, it would be weak and prone to breaking. Once the glass is cooled to an ambient temperature, it undergoes rigorous automatic and optical quality checks for any imperfections. Finally, the continuous ribbon of glass is automatically cut into large sheets for storage and transport. While the float method dominates modern flat glass production, historical and artisanal techniques were used before its invention and are still used today for specialty glass, such as certain colored or textured panels. Generally similar to the industrial process, silica sand, soda ash, lime, but often prepared and melted in smaller batches. Materials are melted in smaller kilns or pots. Shaping techniques for flat glass involve a blob of molten glass is spun rapidly on the end of a punty, a solid iron rod, and centrifugal force flattens the glass into a large circular disc or crown. The thick area where the punty was attached is called the bullseye. A bubble of glass is blown and shaped into a large cylinder. The cylinder is then cut, reheated, and flattened into a sheet on a plate.